Hello class, in this video we will be discussing the decreasing time algorithm, which is a way to schedule tasks on processors. And before we get into the decreasing time priority list, I wanted to remind you guys that in the next few sections we'll be using the same priority list model for scheduling tasks, meaning that basically we're going to come up with a list which tells us how to prioritize our tasks, or basically when we have a bunch of things to get done and we're ready to work on them, how do we know which ones to do first? Um, and the decreasing time priority list is a pretty simple way to get the ball rolling. So basically, with the decreasing time priority list, we're going to prioritize longest tasks first and shortest tasks last. Basically, we want to get our hardest or the most time-intensive tasks done first, and try to fit everything else in after. And if we kind of imagine it like in the last few examples, we were looking at time schedules. We can kind of imagine all the tasks we have as blocks that fit together in order in the time schedule. And if you can kind of imagine positioning those different blocks in different places on a time schedule, the biggest blocks are kind of the hardest to work together because they are, they're kind of in the way. So if we can get those ones done first, it gives us more space to fit the smaller blocks in later. And that's the idea of why this works. Now, this algorithm is not guaranteed to come up with an optimal schedule, but usually it does a good job. And there are some frustrating aspects of this algorithm that I wanted to get to as well as we begin. But let's start with a fresh example, and let's use the decreasing time algorithm in order to schedule the following 9 tasks on 2 processors. And again, you could do more than 2 processors using the exact same processes, but usually, we're going to stick to 2 for most cases. But you could have, it's just like how many employees you have, or it will depend on the situation. So let's get right into it. Let me switch to my whiteboard. So first step is to come up with the decreasing time priority list. So basically, if I'm looking at my diagram with all my tasks, whichever ones are the longest, we want to try to get done as soon as possible. So for example, H is the longest task here, which is going to take, let's just say everything is in hours, 8 hours. But again, it doesn't, we can, as long as all the numbers are in the same amount of time and the task, we don't necessarily need to know what those tasks are, as long as we kind of, we could apply this to any situation in a very abstract manner. But we've got 9 tasks. H is our longest task. So basically, if we were writing a priority list, and usually we'll use set notation to denote our priority list, but how you write it doesn't really matter. Basically, H is going to be highest priority. We want to get that done as soon as possible. And a reminder that we are not actually allowed to start with H because H has prerequisite tasks, right? Like H we're not allowed to do until E has been completed, and E is not allowed to be done until those others are completed. So even though it is highest priority, doesn't necessarily mean we can actually do it first. Then notice that we have 4 tasks that have equal processing times of length 4. So those would all be considered equal in priority, so you could put them in any order you want on your priority list next. But I would generally suggest putting the ones that are, first in our chain, like C is going to be the first ready task, then D and E, work my way from left to right, since we typically make our digraphs left to right in a sensible manner. Next up would be 3, which we've got 2 tasks B and G. But just make sure that all your tasks have a position on the priority list. And last up, A and F are both have processing time of 2. And that does it for our priority list. I have 9 tasks, and all 9 are now in order. And once we have the list, we're going to go ahead and just do exactly what we were doing on the last video, where we now schedule those tasks using the priority list as a guideline. And so my first recommendation is start by circling my ready tasks. So A, B, and C, since those are first on my digraph, those are the only ones we're allowed to do. And so basically C is going to be the first task I work on. Or if I'm looking at my priority list, what you're going to do is you're going to schedule the longest one first and then work your way down, basically. And that's all the priority list is representing. I'll go ahead and build a time schedule because I don't have one here in the packet. But when you're working on the homework, this is going to be something that you're going to want to just build it every time. It's very difficult to try to solve these problems without actually doing a schedule, which you might be tempted to do for the online homework, but it's very difficult to see how all of these events will unfold without working through it in a very step-by-step manner. But anyways, C is going to come first, which is going to be 4 blocks. And when I work on it, when I draw it myself, how I like to do it is I like to put tick marks just to sort of help me visualize, sort of like a ruler, to visualize, well, how long is that task going to take? It's going to, and at the very top, I like to do a tally of the total amount of time that's passed. In this case, on processor 1. And I could label this as processor 1, processor 2, but those are like my workers. And simultaneously, processor 2 is going to work on the next available ready task, which is B. So B is going to take 1, 2, 3. There we go, got B. And I like to use the tick marks to make sure that my blocks are not getting out of sync with each other as time progresses from left to right. And also, remember that as you're completing tasks, so after 3 hours have passed, B will now be completed. I want to check to see, well, does that mean any new tasks are now ready on my digraph? In this case, notice that E and D both follow B, but both of those require A to be finished. So neither of these tasks, D and E, are actually ready yet. So at this point in time, we have nothing left to do but A. And this might seem a little strange because A is very, very late on the priority list, and it's a very low priority task as far as the algorithm is concerned. But since stuff is waiting on it to finish, it makes sense that we want to still do that as early. There's no way around it, because in order to work on D and E, for both of those, A must be completed. And also, at this point in time, both D and E are waiting for A to finish, as are all the other tasks require D and E to finish. So we're going to have 1 hour of idle time in here, unavoidable, because we have to, even though C is completed, A is not. And then once A is completed, now D and E become ready. And so I'll go ahead and circle those at this point in time. And now D and E, and those were the same priority, so I could schedule either one, but they're both 4, so it doesn't really matter. And this would be total 5, and then 5 plus 4 is 9. And same with on the bottom, E. Basically, I'm just going to schedule those 2 next, and thankfully those will both complete at exactly the same time after 9 hours. And then as I'm working, so how I'm kind of visualizing this is I'm working on my priority list, on my precedence digraph. I'm working my way left to right, making sure to not violate any of those arrows. And then in terms of deciding which one to do when, I'm just using my priority list. And now that D and E are completed, and you can X them out on the on the digraph as well as on the priority list to kind of keep track. Now I can see F, G, and H all become ready simultaneously. Of course, I'm going to do H first because that was my highest priority task overall, and H is going to take 8 hours. So 1, 2, 3, 4, 5, 6, 7, 8. And just a little tip for you here is that if you're trying to make tick marks for 8 hours, you only really need 7, because that 7th mark will actually, it'll make a total of 8, if you see what I'm saying. So you don't need to do 8. Anyways, I know that's really basic, but very easy to make that mistake while counting and making little marks like that. Anyways, so then H is in progress. Meanwhile, we could then work on G, which is my next ready task, which is going to take 1, 2, 3 hours. G, putting me at 12 total on processor 2. G would then be finished. That would now F is ready. And after every task is finished, what I would think about, well, is the new one ready? Because technically I is higher priority than F, and it could be possible that I would be what would happen next. But and every single time I'm always referencing back to the digraph to make sure, is something new available? In this case, no, because I must wait for F to finish. But that's a check every single step, and that's something that's really easy to miss. So that's why I'm trying to communicate with you guys is how do I do this, and what am I thinking as I'm progressing through this problem. But there's a series of many steps involved in using the priority list model. But anyways, F would come next, which is going to take 2 hours. Then once F has been completed, now I is ready, and I can go ahead and schedule I on processor 2 as well. And I is going to take 4 hours, so 1, 2, 3, 4. I which would put me at 18 total hours. And that would leave this last little block right there as idle time as well. And I just like to, gray out the idle time to kind of indicate, okay, there's nothing really happening. But that would then be my solution. This would be my finishing time for this project of the 9 tasks. And what I can conclude is that it's going to take me 8 hours to finish all those tasks with 2 workers. And we also have a schedule so that we could tell those workers or computers or whatever exactly what to do when as well. And another thing we can consider now that we're finished with this example is this answer perfect? Is it optimal or not? And given that we do have a couple blocks of idle time, well, 1 hour, 1 hour here, and 1 hour here. My blocks got a little bit misshapen as I progressed. It might not be obvious that it is optimal because maybe we could have shaved off those 2 hours and reduced it down to 17 total hours instead. But given that the tasks D and E were all hung up on A, B, C, and E, this one was pretty much unavoidable at some point because if we add up all the times in those blocks, it's an odd number. And breaking it down across 2 processors means that it's not going to break down exactly evenly. So sometimes idle time is unavoidable, and there is no better solution. But it takes a little bit more of a fine comb to analyze those things such as, is this optimal or not? But in this case, I would say so. And one of the weaknesses of the decreasing time algorithm is that if we're going back to the original priority list, we were jumping around quite a bit, and it did not really help me solve this problem very much. So it did help in terms of telling me what to do when, but honestly, I think it almost makes the problem more complicated at the end of the day. The next algorithm is called the critical time algorithm, and is focused on first finding critical paths and critical times within the project digraph. This algorithm is much more helpful, and I think it's a lot easier to use the priority list generated by the critical path algorithm. Now, you still have to pay attention to each step, and there's some trickiness along the way, but it is a lot better. It's just, in order to do this, we have to find the critical times of each of the vertices, which takes a little bit of effort. And that's what the next video will be focused on, is how do I find the critical path, and then how do we run the critical path algorithm, which is just an alternative to this decreasing time. So decreasing time is nice because it's pretty straightforward. We can get going, and usually it will give me a pretty good solution. Like here, we had very little wasted time. Whereas if I just randomly assigned vertices in some random order, we might, like in the examples we saw in the last couple videos, sometimes priority lists aren't very good. This one usually works out pretty well. See you in the next one.